Hey guys, this is the start of section 6.2, day 1 notes. 6.2 is all about the unit circle. But before we start the unit circle, I need to go over something with you first. I said that in order to redefine the trigonometric functions so that they apply to an angle of any size, we are going to use x coordinates, y coordinates, a circle's radius, and then we're also going to use something called a reference angle. So I want to go over with you what a reference angle is. By definition, a reference angle is a positive acute angle between the terminal side of an angle and the x-axis. So let's find each reference angle. It's not hard, but it's something we're going to need to be able to do, especially with the radians, and that one's going to feel the weirdest. All right, so let's say I asked you to find the reference angle to 130 degrees. Well, the first thing you should do is draw where 130 degrees lands. So give yourself a coordinate plane, just a sketch, and let's sketch where 130 degrees lands. Basically, you need to know what quadrant you're in. So 130 degrees is going to rotate. I start at the positive x-axis right here at 0 degrees. I'm going to rotate this way. So if I go here, that's 0, 90, I want to keep going. I don't want to go all the way to here because that would put me at 180 degrees. And I only want to get to 130 degrees. So let's say that 130 degrees lands right there. It's just an estimate. Okay, so if that's 130 degrees, the reference angle is the positive acute angle between the terminal side, the side where your angle ended, and the x-axis. So this leftover angle right here, from here to here, is known as the reference angle. It's always between where your angle ends and the x-axis. So let's call it theta. So how big is the reference angle? Well, think about it. If you're at 130 degrees and this brings you all the way to 180, what's the leftover space in between? 50 degrees. So the reference angle here is 50 degrees. Okay, again, it's always between where your angle ends and the x-axis. Never go to the y-axis. It's never to the y-axis, always to the x-axis. All right, what about 330 degrees? 330 degrees, where does it land? 330 degrees, if you do your angle of rotation, starts at 0 degrees, 90, 180, 270. I don't want to go all the way to here because that's 360. So I'm going to stop right about there. There is 330 degrees. So the reference angle is going to be the angle in between where your angle ended and the x-axis. So this distance right here is known as the reference angle. Let's call it theta. Well, if all the way around was 360 degrees, what's the angle in between them? How many degrees? 30 degrees. And again, it has to be a positive acute angle. So here the reference angle is 30 degrees. Okay, well, what about negative 135 degrees? Where does negative 135 degrees land? Well, if it's a negative angle of rotation, I have to rotate clockwise now. But remember, the reference angle is never negative. It's always positive. All right, so negative 135, 0, this is negative 90. I keep going. I don't want to go all the way to here because that would be negative 180 degrees. So let's say negative 135 is right there. So the reference angle to negative 135 degrees is this angle right here between where your angle ended and the x-axis. So from here to here. So that is the reference angle. Well, think about it. How many degrees are in between negative 135 and negative 180? That's negative 45 degrees, but your reference angle has to be positive. It cannot be negative. So just say the reference angle is positive 45 degrees. And that's the reference angle. All right, well, what about if they asked you what's the reference angle to positive 48 degrees? Well, guys, draw it. If you draw positive 48 degrees, I start at my x-axis right here where 0 degrees is, and I want to rotate counterclockwise for positive. So I rotate, let's say to there. I don't want to go all the way to there or past it because that's already 90 degrees. So I'm going to stop right about there. That is 48 degrees. So the reference angle is the positive acute angle between where your angle ended and the x-axis. Well, guess what? That is already this angle because 48 degrees is already a positive acute angle. That's an angle that will already fit inside of a right triangle. So it's its own reference angle. So the reference angle to 48 degrees is 48 degrees. It's its own reference angle. So any angle that lands in quadrant 1, again, between 0 and 90, will be its own reference angle. All right, well, what about negative 59 degrees? What is the reference to negative 59 degrees? Well, again, if I'm gonna have a negative angle, I have to rotate clockwise. So negative 59 degrees, I start rotating from 0. I don't wanna go all the way to there because that's negative 90. So negative 59 degrees, let's say, is about there. All right, so the reference angle is the angle between where your angle ended and the x-axis. So again, it looks like it's the exact same angle that we already have, except a reference angle, by definition, has to be positive and acute. So if this is negative 59 degrees, his reference angle will just be positive 59 degrees. Okay, all right, well, what about 240 degrees? What is the reference angle to 240 degrees? Well, let's draw it. 240 degrees. Let's see. I start here at 0, and I'm going to rotate 0, 90, 180. I don't want to go all the way to there because that would be 270 degrees, and I'm already trying to get 240. So let's say 240 degrees is right there. So what's the reference angle to 240 degrees? Well, it's always the angle between your angle ending, the terminal side, and the x-axis. So this right here, that is the reference angle. Now remember, this is 180 degrees. So how many degrees past 180 did you go to get to 240? 60. So the reference angle this time is 60 degrees. One of the most common mistakes when students start working with reference angles is sometimes they'll try to go between your angle and the y-axis. Please do not go to the y-axis. It's always between your angle and the x-axis. Never, ever, ever go to the y-axis. Okay, well, they can even ask you, if I do one extra, what if they asked you, what's the reference to, let's say, 480 degrees? All right, so if you had 480 degrees, right? Well, let's see. 480 degrees is obviously more than one complete rotation. So your angle would go all the way starting at 0. Am I on the screen? Yeah, it would start at 0 and it would go all the way around to 360, right? So now we're at 360. So if I go 90 more, that's gonna be 450 degrees. Okay, if I go 90 more, that's gonna be 540 degrees. So now I wanna rotate to, I get to 480. So 480 is gonna be past 450, so I'm in quadrant 2, but I don't wanna go all the way to 540. So let's say 480 degrees looks like that. So now your reference angle is still the angle between where your angle ended and the x-axis. So this right here. So what is the reference angle? Well, if this is 480 and this is 540, how many degrees live in between them? 60. So the reference angle for 480 degrees is a 60-degree angle. It's that angle right there. Okay? All right, perfect. Well, let me go back. So now what's going to happen is they're also going to require you to find the reference angle for radians, because you're going to be asked questions with trig functions where the angle is in radians, probably more often than degrees. So you really have to get used to radians. All right, so let me start this one, and then I want to show you kind of like a cheat sheet that always helps me, and I'll never forget my teacher teaching me it. All right, so what if I asked you, what's the reference to 5 pi over 4 radians? Well, what I do first is, now again, students say, well, I'll just convert it to degrees. You can absolutely do that. It's just time consuming, and I really want you to get comfortable with radians and what they look like and what they represent. So I think of this as 5 pi over 4 radians. I think of it as 5 pi's over 4. Now, if you remember, when you're in radians, pi is 180 degrees. 180 divided by 4 is 45 degrees. So that is 5 45-degree angles. 5 45-degree angles. So now when you want to go to draw it to find out where it lands, because that's one of the hardest things with radians is, where do I even land? So 5 45-degree angles. You can count that. So if you start at 0, your first 45 would be here, your second 45 would be there, your third 45 angle would be here, your fourth 45 angle would be there, and your fifth 45-degree angle would be right there. So that's 5 45-degree angles. That's 5 pi over 4. Well, now the reference angle, by definition, is the angle in between where your angle ended and the x-axis. So this angle right here is the reference angle. But you want to give it in radians. If the original angle is in radians, then you have to give the reference angle in radians. So how many radians live right there? Well, this is where what I call my anchors come into play. You should remember that in radians, the pi symbol represents 180 degrees. So from here to here, this is pi radians. That's 180 degrees. So if I'm going to work with pi's over 4, create an anchor. How many pi's over 4 would make pi? Do you agree that 4 pi's over 4 would make pi radians? Yes, because the 4's would cancel. So this is where 4 pi over 4's land. So now, how many pi's over 4 land in between 4 pi over 4 and 5 pi over 4? 1 pi over 4. So the reference angle here is pi over 4 radians. So I call this right here, that 4 pi over 4 equaling pi, I call that an anchor. And that's what I use a lot with my radians. And I'll never forget my teacher teaching me. So let me just take one side note really, really quick to kind of show you what I'm talking about with anchors. Okay, so I would like you to remember your anchors. So just remember, all the way around a circle is 360 degrees. All the way around a circle is 2 pi radians. That's our main conversion factor. Then we divide that by 2, and we get our second conversion factor, that 180 degrees is equal to pi radians. So they'll land in the same spot on a unit circle. So 360 degrees lands in the same spot as 2 pi radians. 180 degrees lands in the same spot as pi radians. Well, our main angles that we're going to be working with, especially on the unit circle, are your 30s, 45s, and 60s, because those